Okay, today we're going to be talking about how we can subtract 2 and 3 digit numbers using regrouping, and we're going to use 2 different methods to show how we subtract. So our question is, Claire works in a bakery. On Monday morning, she made 108 cookies. When the store closed that day, she had 86 cookies left. How many cookies did she sell that day? So I started off by underlining the important parts of the question, and then I wrote down our equation down at the bottom, which would end up being 108 minus 86. So to start with, we're going to use the set model, and we're going to be using base 10 blocks. So right now we have one flat that represents 100 and 8 units, which represents the one place, and we do not have any rods because it is a 0 in the tens place. So we need to start off by subtracting 86. So let's start with the units. Since we start off with 8 units and we need to subtract 6, we can do that without regrouping. So let's pull away 6. And that leads us to have 2 units left in the ones place. And now we have to subtract 8 rods. But as we can see from this visual, we don't have any rods to start with, so we can't subtract it. So what we need to do is regroup this one flat into 10 rods. So I'm going to pull this away and put 10 rods, because 10 rods is the exact same thing as one flat. It's just regrouped. So now what we need to do is take away 8 rods. So here's 5, 6, 7, and 8. And we are left with 2 rods and 2 units, which would equal 22. One misconception about subtraction that I feel many students have is how the place values work. So with 108 minus 86, some students think that you can, that they can't take away 8 from 0. So I'm going to put the original back up here. That way it's easier to explain. So some students look at this, and here is what we're subtracting, just so we can see this visually. Minus 1, 2, 3, 4, 5, 6, 7, 8 rods, and 1, 2, 3, 4, 5, and I'm going to grab another one, and 6. So many students might look at this and think, I can't take 8 away from 0, so I'm going to just flip it. And then they would just say, okay, 8 minus 6 is 2, and then change it to 8 minus 0 is 8, and then just drop down the 1 in the hundreds place, which would give them 182 instead of our actual answer of 22. So that's what's really helpful about this visual of the base 10 blocks, because we can visually see that there is nothing here, and we can't take away something from nothing. So we would have to regroup. It's one main misconception. So now we're going to move on to the next way that I'm going to show how to subtract this. So I'm just going to scoot this over there and bring this number line up. Okay. So I have the number line. It's from 10 to 120, so that we have enough space on both sides. So our original number that we start with is 108. And as we can see, my number line goes by 5s. So 108 would be roughly right here. So I'm going to draw a dot right there to know that that's where we start. And I'm going to label 108 underneath it. So I'm going to grab a whiteboard so that I can show our work on this. If I can erase this. So that I can easily show our work, because there's not a whole lot of space up there. So, once again, our question is 108 minus 86. Now, one important thing to do to help kids understand how to do this is let's go to a friendly number. And many students know how to count by 5s. That's something that they learn about in their TEKS, so that's a requirement. So let's go from 108 to 105. So we're going to break down this 86 because we're going to be counting backwards 86 times until we get to our answer. So I'm going to break this down to 80 plus 6 because this is a friendly number, and we know that 108 and we want to get to 105 is 3. So I'm going to break apart this 6 again to 3 plus 3, and then we have the 80 over here still, because 80 plus 3 is still 86. It's the same thing. So now what we're going to do is count backwards on our number line. So I'm going to go one big loop to 105, and that is minus 3. So I'm going to write minus 3 above it so that we know that we're counting backwards 3 times. And then we have 80. So a good way to skip count backwards is to break this apart into tens. So we know that this would be 10 plus 10 plus 10 plus 10. And we're going to do that 8 times. So that's 4, 5, 6, 7, and 8. And then we still have the plus 3 plus 3. And since we already went back 3 times, counted backwards to 3, I'm going to cross that off so that we know that we've already done it and that we still have to do another 3. So now what I'm going to do, since I'm at 105, I'm going to go backwards. Oops, if I can get this. 1, 2, and I'm counting it like this because we know that there's 8 tens. So that's the second 10. Here's the third, 4th, 5th, 6th, 7th, and 8th. So I'm going to write minus 10 above each of our little jumps because this shows that we skip counted backwards 10. And we did that 8 times because we have to subtract 80. So I'm going to cross off all these 10s that we used, and we can see that we still have to go back 3 more units. So now we're at 25, and then 25 minus the 3 units would land us at 22. And I'm going to say that's roughly about right there. And I'm going to do my last little jump, and that's a 3, so I'm going to write minus 3 above that, and I'm going to write our number, our answer at the bottom is 22. So this right here shows us how we could skip count backwards from 108 to get to our answer, which is 22. We did that by subtracting 86, because if we add up all of these little jumps, we get 86. So one way that subtraction relates to addition is like basically they're inverses of each other. So if we take my original equation of 108 minus 86, I'm going to write that out one more time, 108 minus 86, and that would equal 22, which we learned. We proved it 2 ways. For example, okay, I could tell that the students could check their work by adding their total, which here would be 22. So I could say 22 plus what they subtracted by, which in this case is 86. So 22 plus 86. And then if they added that together, because most of the time students learn addition before they do subtraction, they add this together, it should equal the number that we originally started with. And that's a really good way that they could check their work. So if that equals the same thing, then they know that they did their work right, and that also proves that subtraction is an inverse of addition because that works in any case. So that is my D&E.